Now, professional secret, component quality matters. Okay, this is a secret. You should know the component quality. Why? We will see why component quality is important. The quality of your voltage sensing transformers determines the reliability more than the control panel itself. See, your voltage sensing transformer, okay, PT we call it, potential transformer or voltage sensing transformer, determines the reliability more than control panel itself. Because if it will not determine if there is a proper voltage or not at the input, this will not be able to take decision whether to start the DG or not. That is why it is very important. It should sense accurately. I have seen 50,000 USD installations fail because someone used $20 voltage transformer, cheap transformer, inferior quality transformer. It will not sense accurately. Then transformer instead of 200 precision units. So precision is important, accuracy is important for this transformer which is sensing the voltage. Then it is sensing voltage, frequency and phase sequence. All these three things are sensed by this potential or voltage transformer. So this should be very good quality equipment. Okay. Then signs of poor quality component, inconsistent voltage readings. It is not giving consistent voltage reading, proper readings. It is not giving. Though input EB power or city power is stable, still it is not giving proper voltage. Then nuisance trips during minor fluctuations. It will trip the contactor. See, it will give the command to contactors or switching devices. So this is very important, otherwise nuisance tripping will happen. Without reason it will trip, that is nuisance tripping. Failure to detect actual outages. Actual outages happened, power is gone, but still it is not able to detect it. So that is the problem because of this inferior transformer. Then overheating during normal operation. During normal operation, this cheap transformer will overheat. Okay. So these are the problems if you don't use good quality potential transformer or voltage transformer. Now, important thing, critical time setting, mains failure confirmation delay. Now, mains is failed, but confirmation delay is required, right? Whether there is a problem or a small spike, in that case, we should not switch on the diesel generator. Okay. Because it is in milliseconds, why should we switch on? It will be switched on, switch off. So without reason, this is called nuisance. Okay, so we don't want that. So this prevents nuisance starts from brief power interruptions. Okay, brief power, I told you. Too short and you will waste fuel on momentary outages. Too long and critical equipment shutdowns before backup power arrives. Okay. So too long also is not advisable, because then backup units should survive up till that time. So we will see the examples for hospitals, which is very critical, like operation theaters and all. Life saving devices, okay, life critical devices in hospital. So life safety applications required quick responses, 5 to 10 milliseconds. So within 5 to 10 milliseconds, this should confirm the delay. You should keep 5 to 10 milliseconds that power outage is there is a problem in input power. Then start further process, switching process. Then 3 to 5 milliseconds for data centers. So these are mission critical, okay, load. So for that 3 to 5 milliseconds, very critical. That is why less time. For the confirmation, it should confirm quickly. Then to 10 to 13 seconds office buildings, normal load, not to worry. Then 15 to 60 seconds for industrial processes. It can take little more time, but these mission critical things should assess and confirm there is a power problem in the input. Okay, now professional tip, just remember this tip. Check your local utilities average outage duration. It is momentarily or it will take longer time, more than 2 minutes, 5 minutes. We'll see. If 80% of the outages last less than 2 minutes, if less than 2 minutes and it again comes back, then what to do? Set your delay to 30 seconds delay and save thousands in fuel cost annually. But don't do your experiment with these critical loads. This yes, you can do, and you will save thousands in fuel, because it will not kick off the DG as soon as there is a small outage, 1 minute or even less than that, or 30 seconds we have seen. Now, critical time settings. Engine warm up delay. Second time setting. First time setting was confirmation whether there is a problem at the input power. Second is engine warm up delay. Engine should warm up. Okay, it should take proper speed, and then we should put it on load. Okay, modern generators can accept load within 10 seconds. Modern generators are smart. Within 10 seconds, it can take the load. But engine manufacturers recommend 30 to 120 seconds warm up for maximum lifespan. Okay, abruptly or very fast load taking means it can deteriorate its life. If you take 30 to 20 milliseconds, then if its lifespan will be more. So they will advise you for this. Now, engineering compromise, 10 seconds is minimum. Okay, after that it is good. Emergency applications, 10 to 30 seconds. Medical, hospitals and data centers we have seen. For that, emergency 10 to 30 second warm up delay for the engine to warm up. Then normal standby 60 to 120 for buildings and industry. Then peak shaving we have seen a 180 to 300 seconds. If there is a very less time outage from utility power supply, then you can use this. Critical warning, never set warm up to 0, never. Otherwise what will happen? I have seen 200,000 USD engine destroyed by cold start. Full load applications at the cold start, if it is not warmed up properly, and at cold start you just put the load on that at 0% warm up, then it is gone. Your engine will not serve you, it will be damaged. So the fuel saving aren't worth the risking. Okay, it is okay if some fuel is burned in this warm up. Warm up is very important. That is the reason during old days we used to give the heater first, then we used to start the engine of our cars, and we used to wait for some time, and then we put the gear. This is the engine warm up. Okay, now critical timing setting 3, number 3, load transfer delay. Okay, there should be some delay to transfer the load. Okay, this is your safety buffer. The generator must be stable before you transfer critical load. It should be stable. The warm up should be there, and proper speed you should have taken already. Then you can easily transfer the load on DG set. Voltage stability, plus or minus 2% for minimum 5 seconds. Minimum 5 seconds, it should be only 2% plus or minus. Then you're okay. Ensure clean power delivery to sensitive equipment. Okay, it will ensure the clean power. Voltage stability. Then frequency stability, plus or minus 0.5 hertz, half, for minimum 5 seconds. Okay, that much error is okay. This much 2%, 0.5 hertz is okay. For minimum 5 seconds we should check, and then we can transfer the load. Critical for motor loads and timing dependent equipment. Okay, motor and timing dependent equipment, this frequency, minimum 5 frequency is very much important. Okay, we have seen the sine wave, the millisecond, it will change the direction and all. Okay, so for that this is very important. Then recommended total 10 to 30 seconds depending on application. Total what? Load transfer delay. Total load transfer. What? How much? 10 to 30 seconds depending on applications. If it is critical, you can keep less. If it is non-critical like buildings or industry, you can keep even 30-second delay for the load transfer. Balance between quick response and system protection. See, if you keep more delay, or you should judge it as per the emergency or load type. Okay, so quick response and system protection, it entirely depends on that. Now you will ask me, then how much should be the backup time? So industry wise, I have shown you total time. Okay, sensing, confirmation, then what? Delay for engine warm up, and then delay for load. So all these three things cumulatively in total, they should take how much? See, 45 to 50 seconds for hospitals. See, more than 50. So 45 to 50 seconds, 50 seconds, let's say 50 seconds. Then for data center, it is 35 seconds, within 30 seconds even. 30 seconds, 45 to 50 seconds, and then office building, it can take up to 110 seconds. Okay, and then for manufacturing processes, it can take 90 seconds in total. Okay, this is just the benchmarking I have given to you. This is okay. Okay, generally, critical reality check. Your critical equipment must survive this required period without power. This much your critical equipment should survive. For that, we should have the UPS, small UPS for the critical load. Otherwise, it should survive otherwise.